All right, we are going to look at human impacts on ecosystems, and we're going to be focusing just on this short video on biomagnification, what that is. So we can put a whole number of toxins into the environment, and those toxins are the ones that are persistent pollutants, ones that cannot be broken down through cellular respiration or within the body. And there's a number of pollutants that do this, that will end up accumulating in your body, because if you were to ingest it, your body doesn't break it down and excrete it. Okay, so what often ends up happening is it gets stored within your body. So these are persistent pollutants. They're inorganic, so they're not organic. We can't break them down to get rid of them. So examples of these pollutants are heavy metals, some pesticides like DDT, mercury, a lot of the smaller plastics actually, which are those little tiny microplastics in the ocean. Those tend to harbor a lot of chemicals as well that can get that we can't excrete and get rid of. So these toxins end up building up in your fatty tissues. That is generally where it gets stored within our bodies. So when these persistent pollutants, ones that we can't break down, get released into the environment, usually what's going to happen is organisms within that environment that might uptake those, eat them somehow, will absorb them, and it will bioaccumulate into their body, into their tissues. Now, it turns out, though, that if you have a long food chain, the organisms at the bottom of the food chain will accumulate some. But then what ends up happening, because of the efficiency of the pyramids in our ecosystems, of our trophic levels, it tends to actually end up making that toxin more concentrated as you move up the food chain. And the fact that it becomes more concentrated as you move up the food chain is biomagnification. So these two terms, bioaccumulation and biomagnifications, are ones that you need to be able to use comfortably. So accumulation of a toxin, bioaccumulation, is you taking in a persistent pollutant that, or any organism at any level will take in a persistent pollutant. They can't get rid of it, or the body doesn't break it down and excrete it the way it does other things. And then it will probably accumulate within fatty tissues and other parts in the body, the liver or other places. So it's there kind of persistently, like it doesn't go away, and that can build up over time. So you're bioaccumulating it. The term biomagnification is referring to the fact that as you move up the food chain, the toxin becomes more concentrated. Okay, and let me show you why. I'm going to show you a little diagram here. So I'll come back to this. This is just showing you the example of DDT. And so if you look, at this level, the producers, which is often we're talking about an aquatic ecosystem, we're probably looking at microalgae and zooplankton and little things like that. So it could be, it might not be the producers, it could be some zooplankton that are maybe the first level consumers, but you have a certain level that actually is released into the water, right? Well, when they take that up, if you look at that first food chain, so let's say the producers, or the bottom part of the food chain is taking up this concentration, okay, that they're eating it. They might be eating some little microplastics or absorbing some of the DDT somehow. So this is the concentration at this trophic level, at this bottom trophic level. So you can see each one of these little things is referring to how much pollution there is. Well, when you move to the next trophic level, what happens is that all of the carbon that these guys took in through either photosynthesis or from eating other organisms, that gets lost through cell respiration. So you're actually losing biomass at each trophic level, just like the energy. So you lose the carbon, you lose the energy, but what you're not losing is the toxin. So you've got the same amount of toxin, but in a smaller trophic level. And again, at this trophic level, they're going to be respiring, releasing carbon dioxide out. So they're losing biomass as we move from one to the other, and energy, but we're not losing the toxin. So again, you have just as much toxin, but in a smaller amount of biomass. So it's even more concentrated and more concentrated. So as you move up the food chain, it becomes more and more concentrated. All of these organisms are bioaccumulating the toxin, but as you move up the food chain, the concentration gets much, much higher because we essentially have the same quantity of the toxin at each trophic level, but there's less biomass. So because there's less biomass, it's more concentrated because it's not leaving the ecosystem, it's not leaving the organisms. It's not breaking down because it's a persistent pollutant. Okay? So the examples of this, as I said, are DDT. This is a classic example. And you guys watch or will be watching the one on Silent Spring. This is a really important pesticide that, was used throughout, the 50s and 60s and so on to get rid of mosquitoes, and because mosquitoes and other pests on crops and other things, right? And mosquitoes cause malaria, so it's kind of a big deal right at the beginning. But you'll see from the video that that's not, using DDT ends up not actually being the best because, of course, we have bioaccumulation, and we also have the evolution of organisms, the mosquitoes that can actually have evolved to be resistant to it. So you have to keep using more and more and more. And then the other problem was the DDT was killing the bugs that weren't harmful, and so that was disrupting the food chain. So the birds didn't have food to eat. So that was important. The other things, as I said, the big deal now, plastics, heavy metals, those are also a very big deal. The example with the one with the DDT, most of the raptors, like bald eagles and osprey and peregrine falcons, because it was so concentrated, the way that it was really affecting them is it made their eggshells super thin. So when the mom birds would sit down on the nests, they would break their eggshells. And so they were having failed clutches year after year. You need to be able to look at a couple of examples of plastic within the oceans, and bottlenose dolphins and other whales and large mammals, actually, by the time all of that accumulates in their fatty tissues, if they're at the top of the food chain ones, then it ends up actually getting expressed in the mother's milk, and they end up killing their babies. So there's some examples of bottlenose dolphins killing their babies with their own milk. And then because, the mothers will convert a lot of their own fat into milk for the baby. So this is a really classic example of biomagnification with dolphins, and some other plastic things you'll see quite clearly with the albatross, because they think it's a shrimp, the plastic, and they bring it back to their babies, and they can either choke, it fills up their bellies, so they feel full, or it can so that's how they starve to death, or it can be poisoned with some of the plastics. And the bottlenose dolphins and the other whales you see in the ocean that are like eating some of this, or turtles eating plastic bags thinking it's jellyfish. So the plastics in the ocean, not only do they cause like choking, strangulation, but they can also lead to biomagnification in the upper levels of the food web. I'm sorry, it's so depressing.